Welcome to our little humble home in the Philippines. 2 months ago we installed 4 times 130 watt peak solar panels. These panels were supplied with a cheap 400 watt grid tie inverter by the Chinese reliable company through Alibaba.com. Alibaba.com has an ideal combination. In this video I want to show you that this is not a good combination. The weak item in this set is the grid tie inverter. The input range of the inverter is 10.8 to 28 volt. The VMP of the panels is 17.6 volt. Cell efficiency is 15.3%. Because of this VMP, I can choose only for an all panels parallel connection. As an in-series parallel configuration, it will exceed the maximum input of the grid tie inverter. 2 times 17, 34 volt, maximum is 28, so it's not allowed. I will blow up the inverter. This latter is much better, as the inverter can't supply more than 200 watt at an input voltage of 17 volt. And this voltage is established by the maximum power point tracking of the grid tie inverter. I will show the efficiency, also the efficiency of the inverter. Be careful, this is another thing, be careful with ordering through Alibaba.com with Chinese companies. I ordered a rubber boat, which is hanging there in the garage, and now the solar set. After receiving in the invoices, I paid bank to bank through my internet banking, and later received mail from the suppliers that the costs were higher than on the first invoices. The reliable company wrote they would not make any profit, but with the next order they can give me much better prices. Now this is in contradiction, and it's really strange. All the prices must drop that fast, but nobody can look in the future. Probably reliable again. In the total order was around $1,500 US, and I paid $400 US in import duties, VAT in the Philippine customs. The break-even point, better don't think about this. Do it out of idealism, and do it for the environment, because that point I don't think will be there in my lifetime. Okay, it's almost noontime. The sun is on its highest point. The panels, I can adjust an elevation. It's to the best angle now, and the sun is straight on the panels now. I'm going up now to measure the current of each panel. Therefore, I have a DC clamp meter, and I measure the output of all panels. So I show you that all panels are delivering the same amps. Here are the 4 panels, full at the best angle in the sun.
Daddy, you hold something.
This is the first panel, and I measured about 3 amps. Second panel shows the same. Fourth panel, same output. Fourth panel, almost 3 to 4 amps. You can see yourself, it's a clear sky now. This is the control box which I made out of the box in which the solar panels were delivered here. You don't have so many means here in the Philippines, so you have to use all materials. In the front this is when we have a power grid failure, and with this one we start the normal inverter, backup inverter. And on the left side here, this amp meter, you can see the amps going to the grid. Inside the box you see two battery chargers, one grid tie inverter, it's 400 watt. I've had a pure sine wave 1500 watt inverter, functions as a UPS, but I told you. Here I have a very simple power meter, and you can see the output power, but was going to the public grid. At this moment, 194 watt, 192 is being produced as solar power. So for 4 panels of 130 watt peak, this is not much, but I'm sure it can be much more when we have the right grid tie inverter. And I want to show you also how important a good quality grid tie inverter is. For that I'm going to conduct some tests. I'm going to put the 12 volt battery direct on the grid tie inverter, and then it should go to its maximum power. Secondly, I'm going to put 2 batteries in series and do a test with a 24 volt. Now the battery voltage will about be 13.3 volts. So 2 in series, that will be 26.6 volts or 30.3 volts. And then I will measure the output power. There is a remark I want to make with the former test what I did, and that is that I had disconnected the charger, so that people do not think that a part of the solar energy went to the batteries for charging. All the solar power before was available for the grid tie inverter. What I did now, I have connected 2 50 square mm wires, short wires, to the grid tie inverter from the battery, plus and minus. I have connected them straight to the grid tie inverter. And as you can see on the grid tie inverter, there is GTI 400 watt, input 10.5 to 28 volt DC, output 180 to 260 volt AC. Yeah, you should expect that from 10.5 this grid tie inverter is able to input 400. Now, it never tells anything about the output, but that I can tell you now, because the solar panel is 0 amps now, it's disconnected, and we're gonna look. I'm gonna zero the DC clamp meter, and we're gonna look. Hey, we got 12 amps going in, 12 amps. And what do we see? How much power do we get out of it? Hey, it's less, because the voltage is less. With the same amps, it's 144 watt only. The power factor is 0.66. 148, 156, but higher than that. The MPP tracking tries to get the maximum out of the battery. The battery has a lot available. Yeah, it's a 100 amp battery, so it's not able to get more. This is the maximum at this voltage. It's the maximum this grid tie inverter is able to supply to the net. It can't make more. And you see the power meter is running. I want to show you the battery or the input voltage now at the inverter. It's 12.39 volt. Yes, the next test. I have placed 2 heavy batteries in series on the grid tie inverter. The input voltage is now 24 volt. I'm going to put the clamp meter and I'm going to zero it again. Yep. We have here 18 amps at 24 volt. What do we have an output? And look, we had one moment 400 watt. 400 watt. 382, but I saw 400 one moment. But you will see that this grid tie inverter is losing a lot of power over its semiconductors, the MOSFETs. Because I did this test before, and after an hour I could hardly touch that thing. And the heat and the hot air, you can hear the fan pulling air through the semiconductors over the heat sinks. Actually the whole body is a heat sink. The air was very hot, but yeah, we can calculate it. It's not that difficult. We know what comes out and we know what goes in. You see the power now already? Oh, 433. It's getting crazy. While the input source is very constant, the MPPT, the maximum power point tracking, is throwing the power up and down. It's not a constant trigger point. It's getting very hot now. Very hot. You can hardly touch it. It's running now maybe 10 minutes. But that's how the kilowatt hour meters should run. This is also what I expected to get out of those panels. With a clear day like now. And I also noticed, you know, that those solar panels, when they produce more current, they will produce also heat in itself. The internal resistance of the solar cells and the current is producing heat. And the sun produces heat. So what you can do is cool them down from the backside with a water hose, and it's above the pool here. And I saw the power not going up here. I saw the voltage going up.